Hey, it's Mr. Barr, and this is Words into Equations Part 1. Let's get started. Is that a wolverine? It's a cool looking animal. I can use one variable equations and inequalities to model and solve real life problems. Math has its own language and rules. By solving equations, I learn the language of math and how it works. Have you ever looked at a store receipt or bought something online? Do you realize that there are a bunch of equations that are making both of those things work? Computer programmers have created equations that calculate the sales tax, shipping, discounts, etc. Today, at a very basic level, we're going to convert a real-life situation into an equation. Theoretically, a computer program could be written that could actually use these equations. All right, so let's get our notes ready to go. You can start with your name. And Words into Equations Part 1. So, name. So the idea is to take a word problem and turn it into an equation. Here's the basic format that we'll be using today. It's ending value equals a multiplier. I'm going to have to switch to a smaller marker to make this fit. Times a variable plus the starting value. And that should work for, I think, a lot of these. Let's look at the examples that I have here. And the variables, we'll choose smart variables. So instead of using X and Y, we'll use things like D for number of dogs and M for amount of money or things like that. So let's build one. So 331 students went on a field trip. That's our ending value right there. Six buses were filled, so we're going to need that. Seven students in cars. How many students were in each bus? So we know there are 331 students. That's our ending value. And kids in buses. So how many students are in each bus? So we need a variable that represents that. How many students are in a bus? Let's go with S for students. So let me start down here again. 331 is how many kids we ended up with. Our variable is S per bus. We need to multiply that by something. We need a multiplier. Well, how many buses were there? There were 6 buses. So 6 S plus the 7 kids in a car. That models it. 6 buses times the number of kids in a bus plus 7, because those kids are in the car, equals a total of 331. We just modeled this. Let's do one more in our notes, and then we'll do some as practice. All right, ending value 331, multiplier 6 for 6 buses, I chose the wrong variable here. This is wrong. When you see this, I need to fix this for next year. This shouldn't say buses. This should say like kids per bus. Let's try another one. If I can move my slide. Lee had $24 to spend on 7 pencils, so we have a 24. We have a 7, and she had $10 at the end of it. How much did each pencil cost? Let's go with C for cost. Right. So she ends up $24 is how much we started with here, or ended up with, kind of. So the cost is our variable. What are we going to multiply that by? The 7 pencils, right? So the $24 she had equals the 7 times the number of pencils, 7 times the cost of each pencil, plus her change, which is $10. 24. 7 times the number of 7 times the cost of the pencils plus $10 equals a total of 24. Okay, that's it for the notes. Let's just do the rest on the screen. All right, Dale. Dale has $25 to spend at the carnival. Where's this? So 25 equals $4 just to get in, $1.50 for a ride, so 1.5. Number of rides, let's use R for number of rides, plus the $4 just to get in, right? So $4 just to get in, and $1.50 a ride, and his total is 25. So ending value of 25, $1.50 is the multiplier, R is our variable for rides, the number of rides, and 4 is the how much he started having to pay just to get into the game, or into the carnival. $40 bouncy balls, playing horseshoes at her game. Later she gave 2 to each of her friends. She has only 8 remaining. How many friends does she have? Okay, so let's start with that 40. She gave 2, that's our multiplier, to friends, number of friends, F, and at the end she had 8. So she ends up with 8. She gives 2 to each friend, and she has a total of 40 to give away. So 40 equals 2 times the number of friends plus 8. That works. 6th grade class is putting together a variety show. To raise money, it costs $700 to rent the banquet hall. they are going to use, if they charge $15 for each ticket, how many tickets do they need to sell in order to raise at least, this feels like an inequality here. They want to raise at least $1,000. So they need to actually, they will actually want to raise more than that, don't they? More than, greater than or equal to $15 times the number of tickets plus the $700 just to rent the hall. That models it. They want to make more than $1,000. They get $15 for each ticket plus the $700 just to rent the hall. For a field trip, 4 students rode in cars and the rest filled 9 buses. How many students were in each bus if 472 kids went on the trip? Okay, so that got all crazy. Nine buses. And we'll go with S for students per bus. Plus the 4 kids in a car. I don't like that variable S, but we're using it. So 472 equals 9 number of students per bus plus 4. That models it. She's got $250. DVDs are $20 a piece. And she wants to, let's see, have at least, so this is, she wants to stay under this, doesn't she? So can she buy 1 DVD and still have $50 left? Yes. 2 DVDs and have $50 left? Yes, because that, so if she buys 1 DVD, it's going to be 70. She's good. 2 DVDs, that's 90. She's good. 3 DVDs, what are we up to? 110? That's good. 4 DVDs, we're good. 5. She can go up to, what would that be? About 8? No, not 8. 10 DVDs. She can go 10 DVDs and be okay. 10 DVDs, she spends $200, and she still has $50 left. Cooking Club made some pies to sell at a basketball game to raise money for a new math book. The cafeteria contributed 4 pies to the sale. Each pie was then cut into 5 pieces and sold. There were 60 pieces to sell. How many pies did the club make? Okay, so we've got 60 pieces. The cafeteria did 4 pies, but each pie is 5 pieces. So the cafeteria gave us $20, so we have 20 pies just to start. And then, how about 5? So if the club makes 1 pie, that would be 5 pieces with what was already there. That means 25 pieces. So it's not 1 pie. 2 pies would be 10 plus 20 is 30. 3 pies would be 15 plus 20, which is 35. 4 pies would be 5 times 4, which is 20, plus 20, which is 40. Yeah, this is modeling it. That models it. And we could solve this and find out how many pies did the club make? Oh, I guess do we have to solve it? Let's solve it. So the club made 8 pies. Actually, I should solve these, shouldn't I? Let's solve this one. Okay, so we said it was going to be 250 equals 20 times the number of DVDs plus 50, so subtracting 50. $10 DVDs. Well, we decided, so she can buy less than or equal to 10 DVDs. Because if she buys more than that, she won't have the $50 left. Okay, so 472 equals, how many buses were there? 9. I'm going to go kids per bus. It's a better variable. Okay, subtracting 4. Subtracting 4. And divide that, so 468 divided by 9, 52. 52 kids per bus. Right, they want to raise at least $1,000, so we're going to get 1,000. We want to make more than that. 15 times the cost of each ticket plus 700. Subtracting 700 from both sides gives me 300. Dividing both sides by 15. I have to sell 20 or more tickets to make that work. How many friends does she have? So we actually have to solve this one. So I'm going to add or subtract 8 from both sides. Minus 8 minus 8. 32 equals 2 times the number of friends. So that's going to be friends equals 16. Solve this one. The greatest number of carnival rides, so this should actually be an inequality. It should be a less than or equal to. Okay, so let's add, subtract 4 from both sides. That takes me to a 21. Dividing both sides by 1.5. 14. So he has enough money to go on 14 rides, but he can go on less. How much did each pencil cost? $2. All right, that's good enough. Hey, thanks for watching. Have a good day.